Hi learners, welcome to Virtual Chemistry. This is Dr. Padmaja. So today we are going to discuss about chemical kinetics. This is lesson 1 in chemical kinetics. Please subscribe to my channel. Let's continue our topic. So what is chemical kinetics? What this topic used to deal here? So chemical kinetics is a topic in physical science, physical chemistry, where it will deal with particularly rates of reactions, rate of reactions. Then by knowing the rate of the reaction, so we can propose mechanism for the reactions. And what are the different factors affecting on the rate? Etc. And here the term rate in the sense how fast a reaction is taking place. How fast a reaction is taking place has to be discussed in this topic. So based on rates, we can classify reactions into three types. So types of reactions based on their rates. So based on their rates, we can classify reactions into three types. First one is very fast reactions. Very fast reactions. What is the meaning of very fast? So they takes place within less than a picosecond. Less than a picosecond. That means 10 power minus 12. So it is a fraction of a small part of the second. So very fast reactions, very difficult to find the rate of reaction for such reactions. And the second one is very slow reactions. So example, you can take for very fast reactions, you can take the example ionic reactions. So most of the ionic reactions are very fast reactions. And very slow reactions, example, you can say rusting of iron. That takes many days or years. Rusting of iron, they may take years or days to years. So it takes a lot of time. So we can't wait that much of time to determine its rate. Very difficult to determine. The next one is moderate reactions. So moderate reactions means the rate of reaction is measurable. So the rate of reaction is measurable at normal temperature, means room temperature. So generally these reactions are useful to measure rates. So that's the reason why mostly in chemical kinetics we used to deal with moderate reactions where the rate of reaction is measurable. So these are the way of classifying reactions based on their rates. Now let us continue. So what is rate of a reaction? How to write rate of reaction for a particular reaction? If they gave you a reaction, how can you write rate of reaction? Let me explain. Second point, here I am going to explain what is a rate of reaction and how to write this. So rate of reaction is generally expressed by using small r. Expressed using small r. And let's take a general reaction where R for reactants are giving P for products. Generally, whenever the reaction starts, So there will be decrease in the concentration of reactants and there will be an increase in the concentration of products. So slowly reactants converts to products. That's the reason why there will be decrease in the rate of this reactants, and these are the reactants. Whatever you wrote it on left hand side of the reaction are said to be reactants, and here it is generally increases with time. Increases the concentration of product with time. This is product. Then how to write rate of reaction? R is equal to, so decrease in the sense minus we use, minus change in the concentration of reactant. So this is square bracket indicates concentration term. So R for reactants with time, change in time. So you can even express in terms of products as well, because during a chemical reaction there will be a decrease in the concentration of the reactant. At the same time, product used to start to form. That's why you can say it's a positive term. It is forming. It is decreasing, it is increasing. So you can say change in the concentration of product with change in time. So you can express in this way. This is said to be rate equation. So generally this change in concentration term, differentiation terms will be used for instantaneous reaction. And we can use for moderate reactions the same in terms of delta, concentration of the reactant with delta T plus concentration of the product. This is for moderately fast reactions. This is for moderate reactions. So let us take one example, normal example, and then I will explain with the real examples. Let's say A and B are the reactants and they are giving C and D as products. So A and B are the reactants here, C and D are the products. So rate of reaction, as I said, we can define in two ways, in terms of reactants and in terms of products. So rate of reaction decrease in the concentration of reactants with time, or you can say, so that if you plot a graph, you take x and y axis here, this is x and this is y. Let's take concentration term here, concentration of reactants, okay, any one term and with time. So initially before beginning the reaction, the concentration of reactants will be high, but with time slowly the concentration of reactants decreases furtherly and remains stable. Similarly, one more definition we can say in terms of rate of reaction depends on product also. Rate of reaction can be same, increase in the concentration of products with time. So in terms of equation, if I write this, let me write the equation. So rate of reaction R is equal to, whenever you say it's reactant, you have to use the word negative term because it is decreasing. So there are two reactants you can take, that equal to decrease in the change in concentration of reactants. Two reactants you have, you can take any one of this. So this is change in the reaction. Similarly, that can be equated to product as well. Product concentration always should be taken as positive. That equal to one more product also we have, that is D. So decrease in the concentration of D with time. So So if you plot a graph for this, you can get a plot like this. So this is product concentration, and this is time. So initially, the concentration of product is less. Why? Because before beginning the reaction, it is zero. It starts from here. But during the reaction, reactants concentration decreases and products concentration increases, and it will reach stable after some time. And let's take one more general reaction to express where they have number of moles. Here I didn't take any number of moles. One more third case I'm explaining here. I'm going to take a reaction where A moles of A is reacting with B moles of B and giving C moles of C and D moles of D. Here the small terms A, B, C, D are moles of corresponding react reactants and products. So how can we write rate equation for this? Always the moles of the reactants or product should be taken in the denominator. So let me write the reaction here. So rate of reaction for the above equation, rate of reaction is equal to, we can write in terms of reactants as well as products. Let us write both cases. In terms of reactants, see A is a mole, B is a mole. So first let's write for A is the one of the reactants. So always you have to take minus 1 over A. So this is change in the concentration of A with time, that equal to minus 1 over B, change in the concentration of B with time. Similarly, here also you can do change in the concentration of C with time and change, sorry, this is a positive term, change in the concentration of D with time. So this is to be rate of reaction for the equation. Now let us write the rate of reaction for general reactions. So fourth one, what is a general rate of reaction? How can we write a general rate of reaction? Rate R is equal to change in concentration with time. This is called general equation. In this general equation, if you see, C is in the numerator and time is in the denominator. So concentrations units are, let's determine the units for this. Units are, for concentration, it is moles per liter, and T is in the denominator, so T is expressed in seconds. So what are the units for rate of reaction? Moles per liter per second. Moles per liter per second are the units for rate of reaction. So let us start rate of reaction for few reactions. Okay, let's solve few problems. So first reaction example I'm writing here. Nitrogen gas is reacting with H2 gas and forming an equilibrium reaction. That is, ammonia gas is formed. Here are 2 moles of ammonia. Always we should take balanced equation. Now let's write rate of reaction for this. Rate of reaction is equal to, how can we write the rate of reaction for this? So here it is only 1, so no need to write anything. Reactants are, and these are the products. So minus change in concentration of nitrogen with time is equal to So 3 is the mole value. So minus 1 over 3. Change in the concentration of hydrogen with time, that equal to, you can write 2 here is a mole. So you can write minus 1 over, plus 1 over 2. Change in the concentration of ammonia to that of with time. Okay. So in this way, let's see one more example. H2 plus O2 is giving H2. Check 2 moles of H2. So write rate equation for this. Rate of reaction is equal to gas, liquid, take equilibrium reaction. So rate of reaction is equal to, how can we write? So change negative 1 over 2, change in the concentration of hydrogen with time, that equal to change in the concentration of oxygen with time, that equal to change in the concentration of product here is water with time. Okay, so in this way you can write rate of reaction for any given reaction. Only thing you should remember that the moles are written in the denominator as a fraction, and change in the concentration of reactants has to be written with a negative value, and the products should be written with a positive value. So if you understand this concept, you can write rate equation for any given reaction. So carbon plus oxygen is giving carbon dioxide gas. So try to solve this problem. Write rate equation for this. Write rate equation for this reaction. So hope you understood this topic. I will discuss factors affecting the rate of reaction in the next video. Please subscribe to my channel, and thank you for watching.